Hello everyone. Let's begin with a thought. Have you ever wondered how does the energy from the sun end up fueling everything in nature, from a tiny ant to a mighty lion? This is the concept of energy flow in an ecosystem. Energy enters through sunlight, captured by green plants, and then moves step by step through herbivores, carnivores, and decomposers. One crucial point to remember: matter recycles, but energy does not. Energy flow is always one way. It comes in as sunlight and eventually leaves as heat. Let's now trace this path more closely. Producers, mainly green plants, use photosynthesis to convert solar energy into chemical energy stored in glucose. Primary consumers, like herbivores, eat these plants and gain that stored energy. Secondary consumers, like frogs or small birds, feed on herbivores, while tertiary consumers like hawks feed at the top level. Decomposers recycle nutrients back into the soil, but the usable energy is not recycled. As shown in the food chain diagram, sun to grass, grasshopper, frog, snake, hawk, energy is passed along in steps. Now, what governs this transfer? Physics gives us the answer. According to the first law of thermodynamics, energy cannot be created or destroyed, only transformed. The second law tells us that in every transformation, some energy is lost as heat. In ecosystems, only about 10% of energy is passed on to the next level. We can calculate this efficiency using the formula: efficiency equals energy at the next level divided by energy at the previous level multiplied by 100. This explains why food chains are short, usually only 4 or 5 steps long. To represent this, ecologists use pyramids of energy. At the base, producers have the maximum energy, while at the apex, top carnivores have the least. Unlike pyramids of number or biomass, the pyramid of energy is always upright because energy always decreases as we go up. This pyramid clearly shows what we call energy degradation. Each transfer loses heat, so less and less usable energy is available at higher levels. Let's connect this to real systems. In a grassland, energy flows from the sun to grass, then to deer, and finally to the tiger. In a pond, it starts with phytoplankton, moves to zooplankton, then to fish, and ends with a bird. Even agricultural fields follow the same principle, for example, wheat to humans. This is also why vegetarian diets are considered more energy efficient, because fewer energy steps are involved. Now let's solve a numerical example. Suppose a plant captures 10,000 joules of solar energy. At each step, only 10% passes on. Using the formula, energy at nth level equals initial energy multiplied by 0.1 to the power n for the tertiary consumer, n equals 3. So, energy equals 10,000 times 0.1 cubed. That is 10 joules. So, from 10,000 joules at the plant level, only 10 joules are available to the top predator. This sharp decrease explains why ecosystems cannot support too many top carnivores. Let's wrap this up. Energy enters ecosystems as sunlight, is captured by producers, and flows through consumers before exiting as heat. It follows the laws of thermodynamics. Energy is conserved, but much of it is lost at each step, leaving only a fraction for the next level. That's why energy pyramids are always upright and why food chains are short. So to sum up, energy flow is the invisible thread that keeps ecosystems balanced, but it also reminds us that energy is precious and must be conserved. I hope this session gave you a clear picture of how energy flows through life on Earth. See you in the next class with another exciting concept of physics.